Hello, everyone. Welcome. Today is a pleasure to meet you, Greg Restall. I don't know if I don't think he needs an introduction. Originally from Australia, now working in the Arche group in St. Andrews. He's going to talk about modalities and first-order logic combination, a dangerous combination. So I'm very much looking to this. To his talk, so I'm going to just leave you with him.
Thanks, Jose. Thank you all for coming. I'd like to thank Marco, who wisely decided to go to Las Vegas instead of. But we had a good chat. The day before yesterday. Thank you for the invitation and the hospitality. It's been a wonderful visit, and I look forward to coming back. At least if you'll have me back at some point after this production. This talk, as you can see, there's a QR code thingy there and a URL. If you want to download the slides, because there's a lot of material that's in here. And what I'd like, because this is the kind of talk where each section builds up from the previous ones, it would be totally appropriate if you've got any questions of clarification to ask. Just stick your hand up, yell out, ask, if you don't mind being recorded, because we're being recorded. But I want to leave a lot of time for Q&A at the end. Feel free. This is a part of a larger project, a book manuscript that I am wrestling with and trying to finish. And if this survives the presentation today and your objections, which you will leave for a devastating objection, is not a clarificatory question. You can leave that for the Q&A. If it survives all of the discussion and feedback and everything like that, then hopefully, finish writing the book and move on to other things. But this is stuff that I've been thinking about for a long time. So here is the outline of the talk. It only has 7 parts. First, I'm going to set up some background to the problem that I'm going to be discussing. And then we're going to look at, this is a very short section, we're just going to look at a key issue in quantified modal logic known as the issues arising from the so-called Barkan formulas, named after Rous Barkan markers. Then we will look at an alternative way of doing semantics for modal logic, which doesn't make models and possible worlds the central picture, but makes proofs the central concept. And so section 3 is all about sequence and hypersequence. And if you've heard about that, great. And if you don't, this is your lucky day. You're going to learn some stuff, hopefully. Then we will talk about quantifiers and particularly the concept of definedness and the Barkan formulas. And we'll be talking about the work of Sol Pfefferman at that point. Then we'll go back and look at, what does this mean for thinking about possible worlds, and in particular, possibilia, the things that inhabit the other possible worlds that don't necessarily inhabit this one. Then we'll go and do some medieval logic, at least tangentially touch on it, and talk about the concept of ampliation and the work of Max Creswell. And then there's a whole bunch of exercises for you, further questions for you to think about and answer all the questions at the end. So here's the section. We think we understand first-order predicate logic. I teach this to my first years, my second years. First-order predicate logic, the logic of the first-order quantifiers, all and some, talking about things, being able to say things like all footballers are bipeds, Socrates is a footballer, so Socrates is a biped. All footballers' boots are smelly, Socrates is a footballer, so his boots are smelly, all of those sorts of things. We think we understand that logic, and it's settled science. We teach this to our undergraduates, and although lots of people will argue about things here and there at the edges, it's thought to be relatively understood. At least in philosophy departments, especially philosophy departments around the parts of the world where I've been working, modal logic is seen as being relatively settled science as well. We think we understand the way that concepts like possibility and necessity, and I say concepts like possibility and necessity advisedly, Because there's no one concept of possibility and no one concept of necessity. People have realized that there's different kinds of notions of possibility and necessity, whether they be metaphysical or epistemic or deontic or, based on rules or whatever else you might think. But we do think that the notion of necessarily P, a statement is necessarily true, can be best understood in terms of, well, it's true in all of the possible worlds, circumstances, whatever, that are in some sense appropriately related to here. The ones which are possible relative to here. Something is possible if it's true in one of the possible worlds that is appropriately related to this possible world. So we think of that as, that's a really useful modeling heuristic and device. And we've thought that the modal logics which arise from that picture are, the ones. And we think that that's relatively settled. So that's a problem. Because if this is, it's like the problem of quantum mechanics and relativity. Quantum mechanics is really great. Relativity is really great. But bug it if we know how to put them together. I've just recorded myself saying, I'm talking Australian. There it is.
You're in America. Nobody understood you anyway, so that's fine.
Good. Combining them raises questions of its own, which makes us think that, well, maybe we don't really understand these things very well individually, because presumably if something's going to count as a logic, it's meant to be universally applicable in some sense. And noticing that, oh my God, its interaction with something else is complicated and raises questions that we don't necessarily know how to answer in a way that is convincing to all, might mean that the so-called logic playing its, refereeing kind of neutral arbiter kind of role is maybe hard. Maybe it's not living up to its marketing material. So what are these new issues? Well, I'm not going to tell you yet. That's the next section. But the way that logicians have thought about modal predicate logic, this is the logic that you get when you combine modal logic and predicate logic, usually is done by taking the semantics of modal logic in terms of possible worlds and all of that stuff, and the semantics of predicate logic involving domains and assignments of values to the variables and tasky stuff, and sticking them together, it raises the questions that we would like to answer, rather than giving us canonical answers to them, so I think. This idea goes back a long way, goes a long way before, with Barker Marcus's work on the modal predicate logic. And it's a thought of the Antipodean philosopher-logician Arthur Pryor. I'm not going to read through the entire quote there. It's a lovely idea from his Worlds, Times and Selves, where he says, we talk about these possible worlds, and that's really, useful metaphor. However, don't think that in thinking about possible worlds, it's giving you an insight into what possibility and necessity means, because we only understand what the hell counts as a possible world because we antecedently understand what it is for something to count as possible. So it's not like you're running around discovering all these things called possible worlds, and then on the basis of them understanding what it means to be possible and necessary. We first come with an idea of what it is for something to be possible or necessary, and only then are we evaluating scenarios as being possible or not, etc. We understand truth in a state of affairs, or truth in some possible worlds, because we understand necessarily and possibly first, rather than vice versa. And I think Pryor's onto something there that, and there's another quote, which I didn't have time to pick out for, where he says, the conception of models which model modal logics in terms of these points at which things are true and which you're quantifying over them and evaluating formulas with respect to them, is really great in terms of a formal structure, but is not how we understand the modal concepts. We understand modal concepts in some other sort of way. And I think Pryor's right about that. And there is a better way to do semantics, I think, than possible world semantics for modal logic, and that's what I will advertise for you in the section after this one. But here, first, let me make the problem clearer. Here's Ruth Barton, lovely portrait by Renee Pollinger. It's really great. She has, it's not an Etsy store, she has some online store where you can buy cushions and t-shirts and tote bags and things like this with portraits of various philosophers, including this one, which is Ruth Barton with a Barton formula. And then there's another one with the converse Barton formula. I have the two of them on my sofa at home. They're very, very nice. Anyway, here's a formula which is an argument which is equivalent to the one that was on the picture I had before. Does the claim that it's possible that there is an F imply that there is something that's possibly F? Now, this is the simplest sort of question that you can ask combining a quantifier and a modal operator. Can you switch them? Okay, very obvious thing. And in the simplest modal logics, in the simplest way of combining the two semantics for quantifiers and the modal operators, the answer turns out to be yes, it does. And, oh, no, that's the backwards button. Here's the forwards button. So let me step through the reasoning for you. Suppose it's possible that there is an F. And I've just drawn a circle because we all know that worlds are circular. And here is the world that I'll call here.
But a disk.
Oh, well, it's viewed from its side. No, it's viewed from a distance.
Yes.
How? It's possible that there is an F. That means if it's possible, that means that there is a possible world which is accessible from here, and I'll call it there, where there is an F. That's true. Okay, now at this point we do the semantics for there is the existential quantifier, and there is an X such that Fx means that there is a value you can assign to the variable X which makes Fx true. So I'll call that value D, because it's a thing, D. And we assign X the value D, and we say, right, if X takes the value D, Fx is true. That's just what it means for there to be something that's got property F. And so we say, oh, that's great. Okay, but now notice this. When X is assigned the value D, Fx is true there. So I suppose that means from the point of view of here, it's possible at Fx when X is assigned the value D over there. Because what it means for something to be possible is for that thing to be true in some possible world. And Fx, when it's assigned the value D, is possible over there. So it looks like there's a value we can assign to X, namely D over there, which makes diamond Fx true. So, for example, if I have a possible younger brother, if it's possible that I have a younger brother, which I don't, I'm the youngest in my family. If it's possible that I have a younger brother, then it follows from this that there is something that is my possible younger brother. I wonder who it is. Is it you? Etc. Okay. And clearly, the reasoning here is, no, the thing that's my possible younger brother is not necessarily a denizen of here in some sense. It's a denizen of that circumstance where I had a younger brother. Drew, is that a finger?
It's a scrunched up face.
Yeah, I thought
With
so.
a finger,
With a finger next to it.
With a finger next to it.
Yeah,
yes.
good.
You have an open formula. You have a formula with free variables in this other side, and that's the disturbing transfer.
Oh, absolutely. Here, you have been inhabited by the spirit of Quine. I am quantifying in to a modal context. And so, for example, if you think that possibility and necessity judgments are judgments about the provability of formulas or and you think that open formulas aren't really formulas, then you might think that, in fact, I shouldn't have asked the question, there is an X such that diamond Fx. Yeah, absolutely. And that's a way to go. I mean, Quine famously did not think that made any sense.
Yeah, that's his resolution.
That's his resolution of this thing. But yes, it makes sense to say there is an X Fx is possibly true. It's consistent, whatever. But that's a statement about a complete thought or a formula or something like that, and fx by itself isn't a formula. Yeah. Whereas, I like thinking of statements of the form fx as still making thoughts and making judgments, but they might be judgments, for example, which are about things in a way which doesn't involve a name for the thing, like a demonstrative. And I'm saying of that cup, it has some coffee in it or something like that. And I'm making a judgment of the cup. And I say it has some coffee in it. It's not a name, it's doing something else. Now, you might wonder whether that makes sense, whether there could be something, there is something that it's possible that it does, and whether the demonstrative is going to interact well or not with, the modality. All good questions. I want to see whether we can make sense of them, but keeping the specter of, or maybe the only modal judgments which make sense are those which are sort of complete and only don't involve any free variables. That's a specter that I would like to show that we can avoid, but still worry about. Yeah, good question. So, apparently I've got a possible younger brother. Now, that doesn't mean that the possible younger brother has been born, is a person, because it doesn't mean that they're a person. All it follows from this is that they're possibly a person, that in those circumstances where they're my younger brother, they're a person. It might be that they are not denizens of this world in the sense of being present here in any sense of the way that you and I are present here. Don't want to say that. In the work of Ed Zolter, for example, these are creatures which are contingently non-concrete. They are not here in this world, but they're still here to be talked about. And so they exist in the logical sense, but do not in the sense that our quantifiers range over them, but they do not exist in it's a concrete entity, where concrete doesn't mean, the kind of thing that you make buildings out of. I mean, although the things that you make buildings out of are concrete, but then so are you and me and tables and chairs and whatever else. Okay. Okay, so is this reasoning compelling? Well, it's compelling if the objects D, which exists there, are appropriate values to assign the variables here. Okay. And that's not a given. But it means you've got to do fancy footwork to say, well, what are the right things which are able to be the values of the variables in all of these worlds? And the technology of modal models with domains don't necessarily, force you to do one thing or another, but the way which says, okay, the values of the variables are just values of the variables, and that's totally orthogonal to which world you've got, is the most natural and smooth and easy way of combining the models. Contingentism is the idea that says that, no, you shouldn't do that. Some things exist contingently. Some things, exist but might not have existed. The thought is, had my parents not met, I wouldn't have existed. Not that I would have just been non-actualized or non-concrete, and I would have been something else, waiting in Plato's heaven to be actualized in the universe as well. It could have been that some things exist that don't actually exist. That's a way of contingentist, way of understanding modality. It's that existence is like any other decent God-fearing predicate. It varies from worlds to worlds. Okay? Some things are read in this world and not in another world. Some things, in fact, read at a time and not at another time. Some things exist at some times and don't exist at other times. Some things exist in worlds and not in other worlds. It's a natural thought. But necessitism is the idea that, no, that's wrong. Necessarily, all things that exist do so necessarily. So it's not just, the sorts of things that might be, numbers or other mathematical creatures or God, the kinds of things that if they exist necessarily. Well, apparently for necessitists, they're not special with regard to existence. All of us exist necessarily. It's just that we'll exist in very different ways in different worlds. Now, lovely paper by Ed Zolter, who's in the area, and Bernie Linsky, who's up in Canada. Lovely paper, defends this simple quantified model logic. And it's a really sweet paper that I recommend to all of you. I'm going to focus on 3 of the arguments that are in that paper as things for us to keep in mind. Because Ed and Bernie mentioned that there are a range of problems that if you're going to be a contingentist, you've got to answer. One is, okay, if you think there are things that exist in other possible worlds that don't exist in this world, hang on, you're just saying there are things which exist in that world that doesn't exist in it. Your quantifier is ranging over these things, which your models are talking about these things. What? You're making models which have got things which don't exist. It's like, hang on, if I'm building a house and, parts of it don't exist, then they're not really going to be doing house type jobs. If the bathroom doesn't exist. Well, hang on, if I'm building a model and half of it doesn't exist, then how is it doing model sorts of jobs? It's weird. Okay. What am I going to say about these possibilia if they're things which don't exist? How can I coherently talk about these non-existent things? Furthermore, adopting a contingentist modal logic in fact involves revising classical predicate logic, because you've got to allow for terms in some sense that don't denote. And classical first order predicate logic does not allow for terms that don't denote. You're able to make inferences such as if T has property F. Oh, I was told not to write on the green, use the green. Oh well, I'm doing it anyway. Inferences like this, if T's got property F, then something's got property F. That's first order valid. But here, in particular, if I've got something which I got a value in some other possible world, and then I'm bringing it back over into this one with a modal operator, then that was exactly the inference that we wanted to reject. Okay. How can I do that? And finally, contingentism seems inconsistent with serious actualism, which, not all contingentists are serious actualists, not all people that are interested in modal predicate logic are serious actualists, but serious actualism is the idea that the only things that have got, decent God-fearing properties are the things that exist. The only way to be a person is to exist. The only way to be standing up is to exist, etc., etc. The only way to have a property is to have a thing which exists. And once you allow your terms to take values which don't exist in this world but exist in other worlds, then it seems really hard to stop them from having properties. Okay? In particular, they don't exist. So saying this doesn't exist of a thing which doesn't exist seems to be a true statement if you can do it. And, doesn't it have the property of not existing, etc.? And it's be really bad if having the property of not existing entailed existence.
Existing a property?
Always existence, yeah, good question. Yes, it is, but I'll tell you later. Yeah, I'm hardcore. Oh, and by the way, that paper of Bernie and Ed was from quite a number of years ago. Here's some more recent work that has, taken that ball and run with it and run a long way. Tim Williamson's got really interested in modal metaphysics, and this is a sustained defense of not only necessitism, the idea that everything that exists necessarily, but does it for higher order quantification and a whole bunch of things, and does a whole lot of work. And Tim endorses the arguments of Linsky and Zolter, but add some more there as well. There, a big undercurrent, which is made explicit in some places in the book, is that a logic with non-denoting terms, which in some sense contingentists must endorse, is unscientific and not the kind of thing that modal logicians and metaphysicians should be dealing with. They're trying to carve reality at its joints, whatever they are. And also there's a criterion of metaphysical universality, which is a constraint on designing a logic, which is important for Tim. I don't think I'll be able to have time to get into that, but my answer to that is going to be sort of implicit in the answers to the other things. But if you know about that, we can talk about that in Q&A. So that's sections 1 and 2. Sequence and hypersequence. Let's have some fun. This is quick fire proof theoretic semantics. Gamma and delta here are just sets of formulas, sets of statements in some language that you and I speak. And the red and green is really faint on the screen, but I'll show you here. The left-hand thing, the gamma, in that thing up the top, is thought to be, is meant to represent things that we are agreeing with, or things that have been asserted, or things that have been ruled in. And the things on the right are things that you've ruled out. I just want to think that, if you and I are critters that are interested in, navigating our world, and people are saying things, we're often sorting things out into the things that we agree with and the things that we disagree with, and the things that might have been said that we don't agree with and we don't disagree with. They're things which are open, and they're neither on the left-hand side of their sequence or position, neither on the right-hand side. And one way of thinking about the job of logic is it's telling you of these positions, which of them just are self-undermining and which of them are available. Okay. A position, one way of thinking about a sequent of Gensen's sequent calculus is it's saying that a particular combinations of assertions and denials is out of bounds. So, for example, asserting A and denying A is giving with one hand and taking with the other. It's actually being double-minded. It's not a position, it's two positions. A position in which you assert A rules out denying A, and a position in which you deny A rules out asserting A. That doesn't mean you can't change your mind, but to do that, you're implicitly withdrawing the assertion if you then deny something, or you're implicitly withdrawing the denial if you assert it. Furthermore, if you've got a position which is out of bound, then adding a denial while keeping all of your other commitments is not going to help. Or adding an assertion while keeping all of your other commitments is not going to help. You're not going to make yourself return to the field of play by going further out of bounds, as it were, by making more commitments. And furthermore, if one way of reading the cut rule of Gensen's sequent calculus says that if A is undeniable in the strong sense, that denying it is out of bounds relative to everything else, then if the position of everything else is okay, so if the first thing, I've got a little shiny thing here, don't I? Oh no, it doesn't work on the screen. The gamma turnstile A delta tells me that A is undeniable. Adding A to the background context of gamma and delta is out of bounds. Adding A as a denial is out of bounds. But if you presume that gamma and delta were okay, so gamma doesn't entail delta, then adding it as an assertion should be okay. Has to be okay. Why is that? Not okay in the sense that you've got evidence for it or something like this, but if something is undeniable, well, if you and I are arguing about something and I show you that the claim that you're trying to deny this, that's out of bounds, then to assert it is just to make explicit the commitments that you've already got. It's a fun exercise to read Plato's dialogues and find a place where somebody says to Socrates, or Socrates has argued somebody to submission, and they've said, oh, that's undeniable. And then Socrates goes on and assumes that this has been entered into the common ground. Because when I say something's undeniable, that's actually an intensifier. It's saying not only is it true, I've got no way of avoiding it. I can say more about the couple, but I'm going to leave it at that. Yeah. Okay. Now, one way of thinking about logical vocabulary then is that logical vocabulary is a way of making explicit what's implicit already in our practice of assertion and denial. So to assert a conjunction has got the same catch value as asserting both conjuncts. To deny a disjunction has got the same catch value as denying both disjuncts. To assert a negation has got the same catch value as denying the negand. To deny a material conditional, it's a boring, no real connection required, but it's a conditional which says that, okay, what's out of bounds is asserting the antecedent and denying the consequent. Okay? These are really sweet invertible rules in the sequent calculus for the classical propositional connectives, and you can think of them as rules for operating, asserting, and denial. And you could think about those in conjunction with the kind of structural rules, which is just describing the field of play of ruling things in and out and trying to settle issues. And you could think of these as just ways that we could add useful concepts. Because why is conjunction interesting? Conjunction is interesting. Well, we're logicians, of course it's interesting. But why is it useful when, hang on, asserting a conjunction has just got the same catch value as asserting both conjuncts? Wasn't that trivial? Couldn't we replace all of our conjunctions with commas? No, because denying a conjunction does not have the same catch value as denying either of the conjuncts. What I'm denying is it's making that joint commitment something I could object to as a joint commitment rather than as singly. I mean, I might disagree with those two things being true without knowing what the problem is. Okay? In the same way that asserting a disjunction is different from asserting either or both of the disjuncts, and so on. Okay, so that's useful. And yeah, derivations. Stuff follows. This classical logic. It's boring. Okay. Modal reasoning. How do you do modal reasoning? Well, modal reasoning goes beyond flatly asserting and denying. And this is where the possible worlds image is really useful as an image because it is a model of what we do. It's not a model of a reality that we have an independent grasp of. It's a model of what we do when we are trying to reason about and argue about and resolve disagreements about what's possible and what's necessary. Okay. Suppose I say it's possible at P or Q, and you want to know what follows from that. You might go like this. Hang on, if it's possible at P or Q, that means, well, let's just suppose P or Q. After all, you said it's possible. If I ask you to suppose it, if I say something's possible, you can't rule out my supposition of P or Q as being incoherent or anything like that. But my supposition of P or Q is not just, let's suppose it's actually the case. Okay, that's a kind of epistemic supposition, where an epistemic supposition is, oh, maybe this is the case and we don't know it yet, or something like that. And there I'm making something which is like an assertion, but I'm not asking you to call on it for evidence, something like that. That's sort of adding it to my commitment stack, along with all of the other things that I'm committed to. But when we are doing our modal reasoning, when I say something could happen, well, then when I say, let's suppose it does happen, let's suppose P or Q, I'm not saying when it does happen, as it were, is actually now or here. I'm asking you to try on the thought that P or Q, but what I'm letting you do there is throw away some of your other commitments, or at least shelve them or bracket them in some way. When I say P or Q is possible, I might even say P or Q isn't true, but it could be true. Okay? There, when I ask you to suppose P or Q, that's not inconsistent. I'm not just adding something which is inconsistent with my other commitments that P or Q isn't true, but I'm asking you to do your reasoning and do your reasoning in a way where the commitment to P or Q is somehow offline relative to my other commitments. This happens when we are planning. This happens when we are retrospectively imagining what I should have done, when we're thinking about regret and stuff like that. And I'm thinking, oh gosh, I wish I hadn't said that. Imagine, had I not said that, then this would have happened, this would have happened. She would still like me, etc. So here, the arrow is not describing some other possible world. It's just adding this to my commitment stack, but in a way which is prophylactically shields it from the other commitments. Because it might be inconsistent with some of my other commitments. But then I go away and do my reasoning as usual. Because after all, I'm still describing stuff, but I'm not describing reality as I take it to be. I'm trying things on. So, okay, well, what happens if P or Q? Well, could be P, could be Q. Let's consider the two cases. Consider the P case. If the P case is what's going on then, what happens back with my actual commitments? What happens with my actual commitments is, in that case, P is possible. Back there, where my actual commitments were. On the other hand, if it's Q back there, Q is possible. So in either case, I've got P or Q, possibly P or possibly Q. And I think that's straightforward reasoning. And it's not to be conceived of in terms of describing antecedently understandable possible worlds or anything like that. It's just trying on assertion and denial in ways which is shielded from having to be consistent with my other assertions and denials. We're considering options in some sense. So let's just expand my story about positions and say that we could have, well, superpositions has already been taken. So they're they're like extra. Where we're making assertions and denials, but now we're making a whole bunch of different assertions and denials in different zones, where these are trying different things on. And in the case of basic modal logic, that's all I need. Now, it turns out we're very good at keeping track of the assertions and denials in one particular zone as being the ones which are recording what we're actually committed to, and the other ones are kind of subjunctive alternatives to how we are actually taking things to be. And so you probably want to mark one of them as being our actual commitments or something like that. But that's not going to need to play any role in what we do now, but it's a very easy extension to have the modal logic S5 with actuality if you mark one of these things with the actual zone, but we don't need to worry about it. And having all of these different, options that we are reasoning about in a whole bunch of different positions. Again, these are not thought of as describing antecedently accessible possible worlds or anything like that. They're just trying on different kinds. Then we've got the corresponding thing of a hyperposition being out of bounds, being inconsistent, and that's a hypersequent. So what the hell does that mean? Well, here's what it means to claim that something is necessary or to claim that it is possible. Let's look at the possibility one first, because that's on the assertion side. The assertion that A is possible is out of bounds if asserting A in a totally fresh position is out of bounds. That's all you need. That's just opening up a fresh position and saying, well, suppose things go otherwise. And I say, if it turns out that that's ruled out because of my other commitments, claiming that A is possible is ruled out. And just dually to that, denying that A is necessary is out of bounds when denying A in a fresh position is out of bounds. If A is unavoidable, no matter what alternatives I consider, my commitments are taking A to be necessary.
In this hyper sequence,
yep,
the sequence that contains A doesn't have any context.
Yeah, absolutely. That's the point. It's fresh. There's no requirement of bringing in any of my other commitments, because this is purely general notion of necessity, where the only thing that's doing their job is the only thing that's going to be infecting these other zones, as it were, are other modal commitments that we've got. And now, if you have a richer version of necessity than one which involves, taking, the laws of nature or something like that to be necessary. Well, I mean, one way to do that is to record that commitment and say, one of the things that Gamma says over here is the laws of nature are necessary. So then that's going to involve, doing the other stuff. Or there's ways of, making it that when you actually have an empty sequent, the laws of semantics or logic are actually going to, enable stuff to happen there, whether it's recorded or not. So there's ways to go there. So here's the kind of reasoning that I was saying before about the possibility of a disjunction, giving you the disjunction of the possibilities being rendered in this style. I mean, it's chicken scratches. Don't worry about it if you don't care about chicken scratches. But it's got exactly the same format represented in this kind of way, saying that, for example, let's take the line which says P turnstile and then vertical bar, turnstile, diamond P. That's saying a position where I am asserting P over here, but over there denying that P is possible. That's out of bounds. Why is that out of bounds? Because asserting that P is possible and denying P is possible is out of bounds. And that is the one, you're taking the asserting that P is possible and unpacking its cache value and saying that asserting that P is possible is just like asserting P in some other zone. And so asserting P in some other zone, but denying that P is possible is out of bounds. And then just doing all the other stuff, doing all the reasoning, etc. Just does it. Okay. These structures describe patterns that you and I can use to coordinate on the modal concepts in our thinking and our talking. And I think they go some way to providing the semantics that Pryor wanted. If you and I use the modal concepts in this way, and you and I keep track of the alternatives when we're thinking about things, and you agree that when you talk about an alternative, that counts as an alternative for me, and when I talk about an alternative, that counts as an alternative for you, we can coordinate. That does not mean we agree about what is possible or necessary. Any more that if you looked at the rules for and or, and you're all nodding about that and saying, oh, none of you were saying, oh, hang on, that doesn't look like and. Because, you and I can agree that we're going to use and like that, roughly. Or we could, even if you think that's not how your and works, but we could use that concept. And if we follow those rules, it's not like we're going to disagree about how and works, but that doesn't mean we're going to agree all the time about every and statement, obviously. If you think P is true and I think P is false, you're going to think P and P is true, and I'm going to think that P and P is false. Okay? But it's not going to be a problem with and, it's going to be a problem with P, or not P, etc. Yes?
Were these rules reversible?
Yeah, that's the point. These rules are in those double lines are invertible. Yes, these are invertible.
Right. Then formulas which contains a necessity or a possibility, they're going to jump. They could jump from one sequence to another.
Yeah, I haven't. So it turns out here, this is the modal logic S. This is a system for the modal logic S5, where if something is true, if something is necessarily true, it's necessary that it's necessary. If something is possibly true, it's necessary that it's possibly true. Because I didn't say this explicitly, but the different zones, what we've got here, it doesn't matter what order they come in, doesn't matter, anything like that. There's just a, it's a multi-set of hypersequence, a multi-set sequence, and that's enough to tell you that this is the modal logic S5. Yeah, there's a whole bunch of technical stuff that I can refer you to a couple of papers which works through the detail.
But are you deleting the sequence that contains the A or?
Yeah, so here, literally the stuff that's in the ellipsis is any number of other zones. Any number of other zones, and that's the same above and below the line.
Okay. So I trust you, but I don't see how you can recover that. If it is necessary, then it is necessary that it's necessary.
Oh yeah, no, I haven't explained that. But let's do it. Here's why. If it is necessary that it's necessary that it's necessary that okay, let's. Oh, it's green again. Sorry. Let's look at the necessity rule. It says it's necessary that I gives you and it's necessary that I, okay, yes. And then that says, that follows from it's necessary that I, oh, look at that. Now it doesn't matter what order this is.
Right.
And now this means that's equivalent to necessary that I gives me it's necessary that I with an extra thing over there, and that's still axiomatic.
Yeah, I see. Yeah, that's what I meant when I said that formulas that contain a modal operator can jump from one
exactly.
sequence to another sequence.
And that's what happens. You could generalize this if you wanted a different notion of necessity, but then you've got to keep track of a notion of dependence between these things. And so the rule is going to look like, if gamma gives you necessarily in context together with other rubbish, that's equivalent to gamma gives you gamma delta. Something which is, dependent on this one. And so that's kind of, and the structure you're going to get here is kind of like a tree structure. This is what's called tree hypersequence. And Francesca Borgelesi and other people have developed tree hypersequence systems for other things, but we don't need to worry about that here because we're boring philosophers doing simple modal logic. Yeah. Okay. Quantifiers defined in this in the Barkin formula. We should get there. Okay. How do quantifiers work? Well, quantifiers are easy, aren't they? How do you prove that everything's got some property? You prove that X has got that property where you make no other assumptions about X. Okay. I mean, maybe, it's N. I've got my glasses off. You prove that N has got that property where you make no assumptions about N. Okay. That's what little asterisk, Bayes' little fine print says that N is absent from the lower hypersequent, which means in the upper hypersequent, the only place it is in the statement which says A of N. And so you're making no other assumptions about N other than that it's A. And you've proved that N has got property A. So we're not assuming, we proved it relative to our other commitments that N has got property A. So it means everything's got property A because N could have been you or whatever. One way of thinking about this. And dually for the existential quantifier. And if you just do that, the Barkin formula is returned for exactly the same reason in the models. Okay, if there is something that's possibly F, then clearly there is something that's possibly F. I'm starting from the top. And if there is something that's possibly F entails there is something that's possibly F, then if it's possible that N is F, that's just unpacking, because those rules, even though I read them from top to bottom, the two lines means they go in both directions. So if something's got property A is enough to prove other things, then N having property A is going to be enough to prove other things. The other direction is the easier one. We don't need to use the side condition. So if it's possible that N is F, then something is possibly F. But then if it's possible that N is F is enough to tell you that there is something that's possibly F, then assuming that N is F in some other possibility should be enough to tell you that there's something that's possibly F in that other possibility. You might wonder about that. That's what we're going to wonder about. But if that works, then if there is something that's F, it follows in that other possibility that there is something that's possibly F. And so bringing the thing back, it tells you that if it's possible that something is F, then there is something that's possibly F. And that's the proof of the Barkin formula. And the point at which I pause is exactly the same point that the contingentists worry about in the model setting. It's saying, now, hang on, if the assumption over here that N is F is what I'm assuming, that's the Fn on the third line, does that follow that over there is something that is possibly F? Maybe N isn't over there. The N is here. Why does it follow that N has got to exist over there? If N over here is, over here is a scenario where I'm just assuming I've got a younger brother? Does that follow that over there in this scenario, where I actually am, that I have something which is my younger brother? Well, where is he? Etc. Is how the thinking goes. And so this is where we bring in the work of Sol Pfefferman. Because ways of blocking this involve saying, yeah, it's absolutely true over there that n is f. That doesn't follow that n is over here. What there is varies. That's the whole point of being a contingentist. But hang on, I've got a name. It's not like the name disappears over the other side of the eigenvariable or whatever it is that I'm satisfying, the demonstrative. No, it's present over there. So Sol Pfefferman has done some lovely work pointing out that, yeah, just because we've got names and terms for things doesn't mean that there are things that we are thereby naming, and logicians should pay attention to this. This lovely paper, Kantness, I think, called Definedness, just takes seriously mathematical vocabulary. Mathematicians introduce singular terms for a whole bunch of things in lovely ways where the singular terms don't always have values. Fraction terms are really, really useful. 1/2, it's a number. 2/3, it's a number. 1/0, well, no. There is no such thing as 1/0. 1/0 as a term does not denote. 1/2 exists. 1/0 doesn't exist. I mean, the term exists, but 1/0, there's no such number. At least when I'm doing, rational numbers or real numbers or something like that. So, in a natural way of attempting to model the actual logic of the actual reasoning practice of actual working mathematicians, they'll be happy to have the language designed in such a way that there are things which are in the category of singular terms, namely function terms. Take all of, it's not only, the function term like fraction, but, limit terms, sum terms, integrals, all of these things. There are a whole bunch of things where we've got singular terms which denote in many cases fine values, but sometimes those things don't have values in the system that we're talking about. And so if I take that seriously, I've got this claim that I can make, 1/0 doesn't exist, while 1/2 does exist. Perfectly reasonable. And the term 1/0, it's in my vocabulary. It doesn't suddenly, make the page go on fire when I use it or anything like this. It's there in the vocabulary, but just because 1/0 doesn't exist, it doesn't mean that there is a number that doesn't exist. It doesn't even mean that there is a thing that doesn't exist. No, 1/0 is not a thing. That's how it goes. So let's expand our sequence again. We expanded them to make them hyper. Let's think, though, of if we take Pfefferman at his word, then it turns out that my pro and con attitudes towards judgment, saying this is true, this is false, asserting this and denying this, there's also a pro and con attitude towards terms, where I'm ruling a term in as having a value, or ruling a term out as having a value, and saying that, yeah, this term denotes, but this term doesn't. Seems like, this term has a value and this term doesn't, it fails. And so if I take that at face value, then the right way to do the quantifiers in a language where some terms might not denote is to say, well, hang on, just because I've got ft doesn't mean that there is something that has property f. The term t has to have a value. The term t's got to denote for that to work. Just because 1/0 doesn't exist doesn't mean that there exists something which doesn't exist. That's inconsistent. Right? So if I want to prove something follows, if I want to prove that everything's got a property, I don't just need to, it's too much to prove that an holds for every term n, or for an arbitrary term n. If the term n is arbitrary, if an example of an arbitrary term is 1/0, as it were. So if I'm wanting something which, when I say an arbitrary term, I'm meaning a term which follows the logic of any term and has got no distinctive logical semantics of its own, then what I want is to be able to prove that AN under the assumption that N denotes. Okay? And similarly, there is an XIX, tells me not only that that's out of bounds if and only if AN is out of bounds for an arbitrary N. No, it's AN is out of bounds for an arbitrary N that denotes. Okay? And this is a very simple way of incorporating the definedness intuition. And you get a simple logic for, it's a simple free logic. It's the logic that Sol wrote about in the definedness paper in a sequent calculus form. And now the Barkan derivations fail if you just make that one addition. Okay? Because after all, N might denote here, but not there. Okay? N might have a value. There might be my younger brother in this world, had things gone like that. But my younger brother doesn't exist in this world. So he's not a value of the quantifier. So there is an assignment fx, means that given that N denotes and a diamond Fn, then there is something that has, it's possibly F, which tells me that under the assumption that Fn over there, if N exists here, then there is something which is possibly F. But I'm only going to get what I want if the thing which exists here also exists there. So that I could then make it an appropriate substitution instance for the quantifier over there. And that's what we don't have. A term that takes a value here might not take a value there. Seems to me. At least that's natural thought once you've got the idea of non-denoting terms and you combine it with the fact that things can vary from context to context. How things are might vary from context to context. So what this means so far is that I think we've got a natural, usable, contingentist semantics that combines the quantifiers and the modal operators. The Barkan formulas fail in the expected way, and it turns out that what we get here has the logic of a very simple contingentist semantics for quantify this, varying domain quantified modal logic. If you know the details, you know the details, and if you don't worry about it. But here you can think of what counts as a possible world as simply being the reification of an available hyperposition. So it turns out, and I'm not going to go through the details for this, but if a position is available, if you look back all the way back to the cup rule, back here, the cup rule says if a position is available, then it's still available when I throw A in on the left or throw A in on the right. It generalizes to hyperpositions in exactly the way that you would expect. If I had a hyperposition in the zone and the whole hyperposition is available, then that zone could be extended with the A in on the left. And it also works for terms. It's also either going to be available where the term denotes or available where the term doesn't denote. Okay. What that means is...
You mean that we can rewrite this rule to be used with hybrid sequence by writing a bar between the two?
No, not a bar between the two, because these are two different premises.
Yeah.
So I've still got two different premises. One which is this, so the conclusion is going to be this zone with a bar and a whole bunch of other stuff.
Yes.
And
so a couple of hypersequences.
Two hypersequences, exactly. One with a bar and all that other stuff, and the other one with a bar and all that other stuff, where I've taken this zone and expanded it with an A on the left or an A on the right. So it's the sheep and goats thing. So, you're thinking of this process of filling out an available position as, judgment day. And everything in the language is going to be sorted out in each position, in each zone, whether it counts as in or out. And that means, what you get at the limit of that is something which has got exactly the structure of a possible worlds model. But we're thinking of that now as just a reification of the positions that we were taking, which explains why those models are models for, concepts that are being used in this way. So I say, okay, back to here. Oh, yeah, in fact, here. So here's an example of this in a very small way, where we're not going to do this for absolutely everything in the language. So here we're looking at the Barkan counterexample, where I'm asserting that it's possible that something's F and denying that there is something that's possibly F. And so I say, okay, well, if I'm asserting that it's possible that something's F, that means if you push me, okay, I've got to grant in some other position that there is something which is F. But then granting that there is something that's F, I should rule in a term, just a fresh term. If I say there is something that's F and you ask, well, what is it? I say, I don't know. But if I can't suppose that there is something which is F, that's clearly defective. So, okay, you can push me to that. Okay, let's suppose that A is F. And now we look at the claim that I want to deny that there is something that's possibly F. In the first zone, A is possibly F. So I've got to deny that A is a thing. And that's why I've put A on the denial side there. So this is, I'm denying that my possible brother is a thing. And then I keep going and fill the whole thing out. And here, it turns out I'm making sort of judgments about everything in my language, just involving possibility in the subformulas and the formulas that I've got. And it turns out that that's enough to generate a complete description of what's going on in the vocabulary that I've made as red. Here, A and B, I'm ruling B in and A out in the first zone and saying that denying that A and B are F. So here I've got no brothers, even though A exists and B doesn't. They're not my brothers. Whereas there, A exists and B exists in the other zone, and A is my brother and B isn't. Okay, and you could think of that as a little model, which if that's how modal reality is, if you like, then the commitments are coherent and coherent with the original claim that it's true that it's possible that there is an F, and it's not true that there is something which is possibly F, because A isn't something in this zone. A is something over there, but A isn't something over here. Okay. Should I keep going? Yeah. Okay. Possible worlds and possibilia. Okay, let's get back to Ed and first question. What the hell are these possibilia? Okay. Now, and let's just look at this scenario that I was talking about. What is A? What is A? Where I'm thinking about the left commitments as being my actual commitments, and I'm saying A doesn't exist. Okay, but I am saying that over there, had things gone like that, A would have existed. Now, you're wondering, A, well, I don't know who A is. I mean, A doesn't exist. It's not like it's a name, which is, you know, I was baptizing. You know, this is just a supposition here. My commitment that it's possible that I had a younger brother means that I'm taking it in some sense as possible that I had a younger brother. That's just rephrasing the commitment. And so had things gone like that, there would have been something that is my younger brother. And because I've got this sort of existential commitment in that other alternative, I'm allowing an eigenvariable, you know, disposing labels. It doesn't act like a name or anything like that. But it is still, in some sense, a commitment. The issue here, and so some people, when they say they give a kind of reductive account of modal commitment, so those people like Stolnacker or others who, in some sense, say possible worlds talk about propositions or abstracta or something else like that, say that, oh yeah, these things are just abstracta. And yeah, you could say, okay, when I talk about these models, these are just abstract things which are recording our commitment. And so they're no worse a commitment than numbers or syntax or whatever. That's not the point. The point here is not the ontology of the syntax when I'm talking about these models, even though these models are abstract structures. The question is, I'm taking those models to represent commitments that I might have undertaken. And it's the value of the commitment that is the interesting thing. The implicit commitment that's made using that syntax, in particular, if I said, you know, imagine I was committed to there being a planet further out from the sun than Pluto. And you say, well, what is it? And I say, I don't know, but I could introduce a term and say, let's call it Vulcan, something like that. And then what am I committed to when I'm committed to Vulcan? Well, I'm committed to, it's not like there's a particular object that I'm committed to its existence. Okay, in particular, it might not exist. Okay, but still there's this name that I'm using to represent my commitment, and that commitment is the commitment to the existential statement that there is something which has got some property. And so here, the witness here is not a witness to the existence of a thing which has some property. It's a witness to the possible existence of a thing. And so it's a term that I'm using to unpack that. But here, that singular term, I'm not taking that to have a value here. The whole point of it is I'm taking it to not have a value here, but to have a value over there. Possibilia, in this sense, are witnesses to commitment about what's possible. And yeah, I'm committed to it being possible that there's a thing. That's not the same as there being a thing that I'm committed to it. Just like in the case of existential commitment, it's not like we can name the thing, because after all, if I'm committed to there being a planet outside the orbit of Pluto, and it happens that there are two of them, and I said, let it be called Vulcan, which one does it name? Okay, it's not a name. And here, similarly, it's not a name. It's not a denoting term in that way, but it's a term which is used as a witness when we're talking about the logic of and how things would have to either go or it be possible for things to go, for things like that, for those commitments to, be validated. Okay. So they do not need to exist. I mean, clearly the terms need to exist, but the things the terms are talking about don't need to exist for the semantics to work, any more than 1 over 0 needs to exist for mathematical reasoning to work. Because, when you're talking about these positions, etc., you could do this with mathematical reasoning, and I'm putting the 1 over 0 on the non-existence pile. And somebody might then say, well, hang on, you're committed to when you said that 1 over 0 doesn't exist, doesn't have a value, you're committed to this thing called 1 over 0, which doesn't have a value. Well, yeah, I'm committed to the term, but that doesn't mean that I'm committed to there being a thing which doesn't exist, etc. So I think there's ways of cashing out what this possibilia talk involves when you're careful, and we can talk more about it. You can see immediately, I think, that the answer to the second objection, you must revise classical predicate logic, allowing for terms that don't denote. I just, bite the bullet and saying that's not a bug, that's a feature. Treating all terms as necessarily denoting is needlessly limiting, even on scientific grounds. Mathematics is the queen of the sciences, if philosophy isn't. And the revision to standard brand first order logic is totally natural and independently motivated. And this is also the answer to Williamson's objection that non-denoting terms are non-scientific. This free logic is super easy and natural, and I'm not worried about the revision to classical first order predicate logic. The serious actualism question, I think, is a really, really interesting one. I'm not going to have time to go through the details, but there's a way to extend the semantics that I talked about that makes serious actualism totally natural and easy. The idea was you don't have a property without existing, and here this is just a semantic commitment to property talk that if it's out of bounds to rule it, to take T to be denoting, then it's out of bounds to take it that T's got some property.
What's the down arrow?
Down arrow is denotation. That was the denotation predicate.
Okay.
So the line here, 1 over 0 doesn't, that says 1 over 0 doesn't have a value. 1 over 0 doesn't exist. That's Pfefferman's notation.
Okay.
It's just written on the other side to make you think, oh, maybe it's not a predicate, maybe it's, etc. And so this is saying that, F involves existential commitment. F involves denotational commitment. Something. And so if you take the serious actualist thesis for F to be true, namely that if I'm ruling in that the T's got property F, then I'm taking T to denote, because the only way to have a property is for the term that you use to pick out the thing to actually denote, because it's only things that have got properties, then that's a commitment you've got for that predicate. that means that non-existence is not a property.
I don't quite understand. Because you're affirming the first part, it just says that T denotes something.
Yeah.
And from there, you deduce that T has property.
Oh, no. No, that's not that's on the left-hand side. This is saying that if the assumption that T denotes is enough to prove other stuff,
Yes.
then the assumption that FT is enough to prove others.
I see.
Yeah, that would be if it was on the other side. It's
Okay.
if T denotes,
Yes,
then it's
I
got a
understand.
property. Yeah.
That's a form of weakening.
It's definitely a form of, you're certainly saying more when you say that T's got property F than saying that T. It's weakening in the way that adding a conjunct to a conjunction is weakening. Yeah, absolutely. Okay, cool. Thanks for your patience. Now I want to talk about medieval logic because it's fun.
Yeah.
There are around 8.2 billion people at the moment. That's true, isn't it? Some people have died. That's true, isn't it? Have some people died?
Yes.
Okay, but if there are only 8.2 billion people, they're all alive. The dead people, we didn't count the dead people in the first thing,
They are
but we
not.
did count the dead people in the second thing. Okay? If the only way to be a person is to exist, and the only way to exist is to be alive.
But isn't it the first proposition saying there are around 8.2 billion people alive?
I didn't say that. I said there are around 8.2 billion people.
But doesn't it say the same as there are?
No, I just, well, I mean, maybe it is, maybe it doesn't. For a lot of medievals, the only way to be a person was to exist. And the only way to exist is to be alive. Okay, the dead people, they're either alive with God in heaven, or they don't exist now, but they'll be resurrected or something like that. Okay? But the only way to be a person is to exist. And for a lot of them, if you died, you cease to exist. But they've said both of these things are true. Some people have died is true, even though none of the people who've died exist.
Isn't it something like having a false diamond?
Having a false diamond. When we're not talking about people, we're actually implicit. Yeah, this is one way of thinking about this. When we're talking about people in the second thing, we're not talking about existing people. We're talking about past people. Because have died involves a backwards temporal connective. And that expands the range of the quantifier in modern vocabulary. That ampliates the term people to not only include current people, but past people. So the natural use of the term, when I'm counting people, I'm counting people. But when I introduce the past term, I'm not only counting people, but I'm also counting past people. And so the term has been ampliated. Socrates taught Plato. That's true. Socrates doesn't exist. That's true. The only way you can teach someone is to exist. There is someone who taught Plato. But the there is, when I say taught, the there is now not just talking about actual people, existing people, it's also talking about past people. Okay? And so for medievals here, you had to pay attention to the temporal modifiers of the verbs, which expanded the range of the terms around. And so Max Creswell, in his lovely book, Entities and Indices, talks about the application of the medieval theory of ampliation to talking about modal and temporal predicate object. And it's really, really sweet. Ampliation, one connection with ampliation is in the use of anaphora. Anaphora are these pronouns which can point to earlier discourse items. I used to have a pet budgie gull. You know, they're often pets, especially in Australia. I used to have a pet budgie. She was called Barbara. Okay? The Barbara doesn't exist. Barbara died. Okay? I used to have her. When I say I used to have a pet budgie, the have a, the existential quantifier that's implicit in that is under the backwards temporal modifier I used to have. But now I can introduce this anaphora to it very naturally and say, she, and then tell you something about her. She doesn't exist. She used to exist. She's dead. But we can do anaphora not only backwards temporally, we can do anaphora counterfactually. Had things gone differently, I could have had a pet dodo. Had people not been so stupid as to kill and eat them all. Alas, she doesn't exist. But I would have loved looking after her. That's totally natural. Because what happens with these claims, we introduce discourse markers to when we talk about things, including existentially quantifying things, including when we talk about things and introduce them under modal temporal operators. Okay? I say, this used to happen, blah, 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 and I introduce a term over there, and then I bring the bloody thing forward over here and talk about it. And I can do that for counterfactual things. Okay? I could say, had I had a younger brother, I would have fought with him. A very natural thing to say. Okay. I'm glad I don't have one because I don't like fighting or something like this. So ampliation is really, really interesting. Ampliation takes a term that's defined in one zone and uses it in another. And we do this all the time. If I do this, then this motivates another kind of quantifier. Because a term here that has a value in some other zone, I might talk about it just by dragging this discourse marker over here, which we do. And then these are things which might not exist over here, but I can still in some sense talk about. And the fact that now, let's look at the existential rule. It says that, there being a thing in the broader possible sense, there being a thing with property A is enough to prove something. If I can assume that N has property A, but now I'm not assuming that N exists here. I'm assuming that N exists somewhere, as it were, and I'm imagining the referent to the N being dragged over here. And I think this is totally natural and totally makes sense, but I'm not saying that N exists. I'm just saying there is something in a very thin sense. And same for the universal quantifier, it's just in the view of time, I'll go through that. And a lovely thing about that is you add terms, quantifiers which work like that, the Barkin formulas come back, as they should. Because now, if there's a possible thing, which is possibly F, then of course there's a possible thing, which is possibly F, and that just means that, the value N, the term N takes a value somewhere. And over here, we assume that it's possibly F. And, that's clearly enough to say that there's a possible thing that's possibly F. And well, if N is possibly F, that just means in some zone we've got Fn. And then that's just unpacking that. But hang on, if in some zone I've got Fn, and in some other zone N denotes, then by doing that ampliation dragging the value of N from over there to over here, we're saying here, the claim that there's a possible F is enough to tell me that there's possibly a thing which is possibly F. And so that means that if it's possible that there's a possible thing which is F, then there's a possible thing which is possibly F. And that is totally not inconsistent with contingentism. It's totally consistent with contingentism, but you've got a way of having this outer quantifier where we are talking about these possibilia in a way, we're explaining this merely possible thing discourse in a way which is allowing our quantifiers to make sense, talking about things which don't exist. The talk of possibilia, though, with this outer quantifier, I think is, if you bought the story that I had before, it's as ontologically innocent as that story. The possibilist quantifiers have got the sense that they do, given the distinction between referring and non-referring terms. Okay, now there is a sort of three-stage difference between terms. You've got terms like 1/0, which don't denote regardless. Okay, then you've got these terms like n, the values of these possibilist quantifiers, or the values of quantifiers under modal operators. Had things gone differently, this would have had a value. And then we are taking this, counterfactual supposition and anaphorically using the terms which are defined there to say things over here. We're doing that. And terms which have values somewhere have got values in the extended sense. But the only sense that they have values is that they exist somewhere. Okay? And then you've got the things which exist here, which are the things which vary from world to world. And so to accept these outer quantifiers is to reject the Quinean dictum that to exist is to be the value of a bound variable. Okay? You're still saying some things exist and some things don't. Okay, so you're a non-Quinean to that regard. Hey, we're not a Quinean in the sense that we're quantifying in left, right, and center. That seems all right. So the result, I think, is a coherent and motivated contingentism with inner and outer quantifiers. A semantics is grounded in our practice, our practical norms for using these modal operators and the quantifiers. Done. Okay, exercises for you. Here we go. What about the identity predicate? Is it definable or not? Is it? Yes, it is. The thing is, it's definable in a number of different ways. If S is identical to T, does that tell you that S and T exist? A natural way of defining identity is in terms of indistinguishability. It's in terms of, indiscernibility of identicals, defining identity as indiscernibility in some sense. If I have that definition and the F is really general and is not just an existence entailing predicate, well, if it is an existence entailing predicate, then it turns out that 1/0 equals 1/0. And in fact, all non-existent things, as it were, are identical to each other because none of them have got any properties. Some people say that, hang on, 1/0 is not identical to 1/0. Identity should be existence entailing, or at least possible existence entailing or something like that. And there's a bunch of questions around that, which I think there's a range of options and we should just examine them all. What about second order and higher order logics? They seem to be all the rage these days. How do they work? Yeah, there's a PhD thesis for you. More interesting thing, I think, is epistemic and metaphysical modality. I think the kind of thing that we do when we say, had things gone differently, or the kind of thing that we do when we say, I think this is the case, but you think it doesn't, you might be right. Let's suppose you're right. That encodes a kind of epistemic possibility and epistemic necessity, which works differently, similarly, but differently to metaphysical. I think, if A is identical to B, then had things gone differently, had A been F, then so would B. That's obviously valid. If Hesperus is phosphorus, then were I stupid enough to plan a holiday in Hesperus, then if I do that, I'm going to find myself at phosphorus. Okay. Whereas, hang on, you think that Hesperus isn't phosphorus. Well, if you're right, Hesperus might be sunny, but phosphorus might be rainy. Okay, that's totally coherent. Whereas it's metaphysically necessary that if P is the case, then it's actually the case. That's controversial, but I think it can be defended. But it's not epistemically necessary that if P is the case, then it's actually the case. Okay. No, hang on, that's the wrong way around. Yeah. Sorry, I'm getting brain fade. I should stop. But anyway, there's a difference between metaphysical and epistemic necessity around actuality. Okay, I think this is a second last point. I've got inner quantifiers, which are the existentially committing ones. I've got outer quantifiers, which are the possibilist ones. What about way out quantifiers, which don't give a shit about whether terms have got values? Okay, these are definable in some sense, formally speaking. Do they make sense? In that case, if the pi here is, the product or, universal, the really universal quantifier, which doesn't care about, whether or not singular terms have got values. So there, we'd be able to prove sigma is the, particular, not existential. And so the claim sigma x, not x denotes, there is something which doesn't exist. In fact, sigma x necessarily, there is something which necessarily doesn't exist. Follows from 1 over 0 necessarily doesn't exist. And that seems weird. That seems weird. Maybe it's true, maybe it's not. But I think that is connected to the next question, which is what is a variable? Often we think that variables are the kinds of things which can take different values, whether taking values, things which really are values here, or at least potentially take values had things gone different and been ampliated back into this context. And 1 over 0 just doesn't have a value anywhere. And quantifiers seem to involve variables rather than just syntactically generalizing over arbitrary singular terms. And I think there is a difference there, which is worth making clear. Okay, serious actualism as well. There's more questions about that than I talked about. Is there a coherent way to spell all of that out, especially when thinking about identity and second order quantification and things like that? These are all a whole bunch of issues. But there are probably more issues than that, which I should leave you time to ask me about. Thank you very much for that.
Thank you so much. Is there any question in the room? Yes, Pino?
When you wrote that thing in green on the whiteboard,
This one?
yeah.
Oh, yeah.
It reminded me of the paper by Dana Scott on identity and existence. Then one of the questions you mentioned involved identity, and what do you think? I mean, for instance, he introduces a formula to speak about existence, and that rule is not correct. You need to add one further hypothesis there, for instance, in that form.
And so for me, the rule with that form, if I was doing it natural reduction wise, the further thing is in the that. If I was doing
That's
it,
Scott's solution as well.
yeah, that's Scott. Yeah, and so I mean, I'm doing so Scott's stuff, and there's a whole tradition in I know this from sort of Lambeck and Scott and sort of internal language toposes and stuff. So that's not Dana Scott.
No,
that's Philip Scott.
that's it.
So I know also the sort of extension of things allowing for non-denoting terms also to come from there. But that's a natural. So I wasn't claiming that Fetterman's the only place, but it's the system which is a very simple modification of classical predicate logic. But yeah, Scott and other examples sort of show that there are people that you wouldn't say are, peddling an unscientific language or anything, that are talking about thinking of the importance of languages with terms that don't denote terms which are in the language, which not necessarily by themselves an appropriate substitution instant quantifier without an extra assumption. So I will track that down and look at what Dana says. about the interaction of identity and existence as well. Because I mean, it's trivial in one sense that T exists is going to be equivalent to there is an X, and X equals T. For me, no matter what. But that's because this is the thing, which is existence in turn. You might have 1 over 0 equals 1 over 0 on some semantics of identity. Yeah.
If I can,
Of course, yes.
because he also has a second predicate to denote possible identity without any modality around. Yes.
And Pfefferman also has, I mean, in Pfefferman's case, there's a weak and strong identity predicate as well, but the weak identity predicate is, S equals T is either S strongly identical to T, so the strong identity predicate, or T doesn't denote and S doesn't denote. Yeah. And so all non-denoting things are identical, which not going to be useful here probably. But yeah, I'll have to, I've read the Scott paper, but not while thinking about this. So thanks for the reference.
Can you go back, I think, a few pages and show us the rule for the possibilist quantifiers again?
Yeah, also,
I want to take a good look at those.
Yeah, please.
Because isn't there a dual for all box?
Wow.
A necessitive version?
A necessitive. Oh, that's really interesting.
I mean, there is. Formally, there just is, right? Now, if N is on the other side of the turnstile.
Yeah. Oh, hang on. No. If N is on the other side of the
turnstile. Well, you see what I mean?
No, they're things which necessarily don't exist.
Right. So, but my point is that just formally there is there's another dual pair.
Yeah, good. So you're saying that.
And I don't know what they mean.
Yeah, no. So this is where the only thing that I do is I swap the side of the N. And they're going to be the things which so they're things that possibly don't denote. So
right.
So this is saying the only, and so this is, that's interesting.
Right.
So that's going to say,
God might not be one of those because that might not possibly denote.
Yeah, but 1 over 0 is definitely one of them.
Mm-hmm. Mm-hmm.
Yeah. So that's interesting.
I think you have another dual pair of.
Yeah. So that's interesting. I will need to think about that. I think if the only side, I'm very tempted with the idea that one should take seriously the fact that these are variables that are bound in the quantifiers. So the X's are variables. And I really think that one should take, I think that there's something there, together with the fact that in rules like this, there's a nice constraint on these rules that the things above the line are in some sense constituents, implicitly or explicitly, of the things which are below the line. And there you might think that, wow, hang on, if a variable is the kind of thing that either has or could have a value, then merely saying that N doesn't denote somewhere might allow in too much, might allow the terms which are necessarily defective. I mean, clearly formally works and everything like the way out quantifiers do. And so not saying as a logician, let's not figure it out, because I think that's totally right in terms of technical and formal exercise. I do think there was something in the ampliation story of, okay, to have a value is either to have a value here or to have a value somewhere else and dragged in contextually to here. And, but I do like the idea of fiddling things around. I'm actually, in the bit that I'm working on at the moment, there's, I haven't really said anything about why I've been using these double line rules, but there's something about really treating these things as definitions, sort of, because they're if and only if equivalent things. And the thing is, you can get from these double line rules, Gensen style left and right rules in a totally algorithmic way, and in such a way that there's a nice harmony between the left and the right rules, which allow for co-elimination, conservative extension, blah, blah, blah. Don't worry if you don't know the details of that. But the thing that I'm writing at the moment, and trying to nail down the form of the proof, is sort of the general structure of anything that's sort of definable in any kind of way. And the thing that I'm working on at the moment will allow for things that have the form that you say, because, the thought is, I've got an operator here in front of something. A general operator is going to bind some number of variables, and it's going to involve some number of subformulas. Conjunction has got 2 subformulas. Box has got 1 subformula. Universal quantifier binds 1 variable and has a subformula. But in general, you could have n variables, n subformulas, and the thing that you need is, above the line, how many premises do you have? All the examples I've had have had 1, but in general, you could have more premises above the line. And then you need to know, of all of these subformulas, where do they go? And you could just say, right, some go here, some go here, some. And it turns out anything which has got that structure defines a concept, which could be added to some vocabulary, which in some sense has a meaning, which is logically well behaved. It's an insane sort of general result. When it comes to and or and not, it turns out that any of the things that you could define like that in the propositional language, just in terms of sequence, is definable in terms of the Boolean key. Okay, so it's not really adding anything in the classical context. It's more general in sort of linear logic. But in this modal quantificational setting, it's going to be interesting to know, in cases like that, in the general case, like just picking an example, you say, well, when I do with this variable, it goes over here rather than over there. What is that going to be expressible in terms of other vocabulary? Or is that a genuine new thing? My conjecture is it's going to be expressible using the other vocabulary together with a way up quantifier and the modal operators and being able to explicitly talk about existence.
I think it might be even more direct than that. If you have classical negation, I suspect that what I just suggested is just exactly the De Morgan duals of there too.
Yeah, and so that's going to be
the 2 things that you have.
Okay, no, these 2 things are De Morgan duals of each other. Because this is I don't have them on these slides. Possiblest.
But the n is on the positive side.
This is full x, possiblest full x fx is actually way out x possible possible x denotes implies fx. Okay, because that's then this is the De Morgan dual of that. Not product is sum, and then not this, and then we'll do the this is the De Morgan dual of this is going to be possible x nodes and fx, because of the way the restriction works with the De Morgan stuff. So I think the things that you have will be duals of each other because of the way that quantify restrictions. And but maybe I'm wrong.
Will you take questions from remote participants?
Hello. There's a question from Ed.
Yeah, please go ahead.
Hi, Ed.
We can hear you.
Hey, good. Nice to see you again. Thanks for the talk. Really interesting, Greg. I enjoyed it a lot. I just wanted to make one observation and then raise one concern.
Excellent.
The observation is that the way you characterized some of the points we were making about the contingentist one of them didn't quite resonate with me, and that's the thing about denying the existence of non-denoting terms. I've never really denied the existence of non-denoting terms. I think, for example, we need free logic to understand the logic of definite descriptions. And I've always been, in all of my works, I've always allowed definite descriptions to be non-denoting, and I've included a free logic for them. The thing I've always objected to is to use free logic to do metaphysical work, such as, trying to, use free logic to deal with fictional characters, which strike me as things that you've got to have terms that denote rather than non-denoting terms. Anyway, so I think you put that just a little too strongly, and I think our real concern was that Kripke had to get rid of constants from his language. I mean, so that he would avoid free logic, and he had to do all sorts of other things to the syntax and the reasoning principles of quantified modal logic in order to avoid certain consequences. So that I would put it in those terms rather than.
Okay, that's really helpful. That's really helpful in
So
terms of
that's the observation. The concern is about the truth conditions of iterated modalities. Now, at the end, you went on and pointed out that, if you look at anaphora, the anaphora data suggests that you've got to bring on board a new pair of some new quantifiers, the ampliative quantifiers. Okay, so now you have to admit that one of the costs of this program is that you need two kinds of quantifiers, whereas before, the view that Linsky and I have proposed only can get by with one, because we can with all of that anaphora with the quantifiers that we have. And the concern that I have is that you've also made your quantifiers, the original ones, non-objectual, because you say you're no longer committed to the possibility, but you are committed to the terms, but it's not the terms that are the witnesses to existential claims, it's the things in themselves. So that means that when you get to iterated modalities where you don't have anaphora, so something like this, you might have had a younger brother who might have been prime minister. Okay. Good. And now there's no anaphora, but the truth of that claim, if you look at what it means, it suggests that this thing, your whatever it is, this possible brother, that's the thing that has a modal property. And it's not a term that has a modal property, it's that thing. Because terms don't have the right modal properties to be possibly prime minister. So I think the concern you've got to address as part of this program is to point out how the non-objectual quantifiers are going to get you out of this question or concern, out of this concern about iterated modalities, where it looks like the meanings of the original modal data suggest that we really are postulating modal properties of these possible, or I would say contingently non-concrete things.
Yeah, sure. Yeah, no, that's really helpful. Thanks, Ed. What can I say? The points about you're accepting free logic for other purposes, not wanting them here, and the background to the difficulties being how Kripke had to deal with things. Take all of that on board. I'll incorporate that. The question about iterated modalities and truth conditions for claims which involve iterated modalities like this, especially ones where the discourse does not seem to explicitly involve an introduction of an anaphoric referent.
Right.
That's really good. I've said nothing about the truth conditions. The proof theoretic semantics does not explicitly give meanings for things in terms of truth conditions. That does not mean I don't think that things have truth conditions, but spelling out how the truth conditions are connected to the rules for use that are given here is going to involve the same sort of story that somebody like me, actually me, who does the same thing for predicate logic is going to say about the semantics of the quantifiers, where I say exactly the same thing about the relationship between these rules and models and tasking models for, first order predicate logic, as I do for the modal logic and models and the idealization and etc. So in particular, the kinds of things I was saying in terms of what commitment to an existential claim means in terms of, there being a value for the variable and spelling all of that out and explaining how the eigenvariables that we use in spelling out a model, which is going to be a model which spells out the commitment that I'm undertaking when I make an existential claim, and how that falls short of, there being a name in my vocabulary for the thing, is the same sort of thing that I'm going to spell out in terms of both how to understand the things that are models, but then how you bring that back to asking, what is the truth? Now I'm not interested in the model just as a technical device or a reification as a representation of what might be a counterexample to an argument or might be a way of spelling out how things might go. But if I'm talking about, honest, God-fearing truth conditions, then I want to say something about what it takes for this thing to be true. And I've not said anything about that other than homophonic truth conditions, saying that there is an x such that f of x is true, if and only if there is an x such that f of x. And I can spell that out further and say, there's a thing, which is a value of the variable x. And what does that mean? That thing actually has the property f, etc., etc. But that's going to be further spelling out things in terms of the concepts that I've given a semantics of. Now, I think there's more to say about truth conditions than that, but that's going to be the way that I'm going to go. And saying something that commitment, especially to the wider quantifier, involves a kind of commitment, but it's not syntactic quantification. It's not, although there is substitution involved in the semantics, proof theoretically, it's not a truth conditional semantics which says that a statement, there's a possible x such that it's an f. That is not a commitment to the existence of a term, which is a substitution instance, any more than same thing in the case of first order quantification that's a not possibilist. But I need to say more about that. And I want to be able to say something about truth conditions.
Yeah, because if you don't, then it just looks like we're doing different things. We're not even trying to, we're involved in different enterprises.
Oh, well,
because
yeah.
Litsky and I thought we were, that the goal was to give truth conditions, and in such a way that we preserved all of our logical intuitions about objectual quantification, and that we thought real metaphysics needed to be done and not just model theory. And so that's partly why that just drove us to this position, that there are these, because after all, people were, it's not like existence, it comes with an implication that the thing is physical, because people want to say that sets exist without implying. So we just figured you might as well just have more objects except
I love the logic, I love the work that you've done on this. It is true that at some level the proof theoretic semantics is a different enterprise.
Yeah.
And it's true that at some level it isn't. It's attempting to give a semantics. It's attempting to give a semantics which says something about how we acquire and use the concepts and why it is the concepts have got the meaning that they do.
Right.
It does definitely say something about truth conditions, but that involves saying something about the concept of truth and saying something. So here the primitives are, what are the commitments that are involved when I make the assertions and denials and say stuff involving the vocabulary? Then there is a question, what further goes on from that? What would it take for it to be true?
Well, don't get me wrong. Don't get me wrong. I'm all in favor of your program of proof theoretic semantics. In fact, I'm a fan of it insofar, especially insofar as it relates to the meaning of terms that denote abstract things. I think you've got to go proof theoretic, extract the meanings, and then once you've abstracted the meanings from the things we say about, it's like the Canberra plan, right? You basically, and then you can give a truth functional analysis once you've got the objects in question. But I don't think that it works as well for things that have to do with concrete things or possibly concrete things, because they're given, the first are given an experience here and the others are given an experience in other possible worlds. So it's like they're immune to the proof theoretic treatment of them because they're things there. They're really human beings in those other worlds, right? And so you really wouldn't want to treat them as abstracta. So that's why we distinguish between true abstracta, which are necessarily non-concrete, and the contingently non-concrete. They're different kettles of fish.
Yeah,
So,
absolutely. Absolutely. I take that point. And this is really, really helpful.
I hope we'll get a chance to talk with this. Are you going to, I'm giving a talk in the Australasian meetings in the formal methods of philosophy track in honor of Max.
Yeah, absolutely.
In Queensland, will you be in Brisbane so that we can
no,
talk?
I won't, unfortunately.
Too bad.
I will be in Scotland at the time.
I see, too bad.
But yeah, no, that sounds like a lot of fun. I wish I could be there.
Yeah.
But thanks, Ed. I really appreciate it.
Yeah, sure. Nice talk.
Thank you.
Is there any other question in the room or in the chat? Yes, please go ahead.
So if I was following you, one of the moves you made was you want to keep the Barkin formulas and serious actualism.
No.
Which Barkin formulas? Possibilist quantifiers or inner quantifiers or outer quantifiers?
Well, you tell me which way.
Because I reject them for the inner quantifiers and I accept them for the outer quantifiers.
Okay.
Because I don't think that if it is the case, so I don't think that if it's possible that I have a younger brother, that there is somebody that is my possible younger brother.
Yeah.
But I do think that there's a possible thing that's my younger brother. And I do think that that's a quantifier, but that's the outer quantifier.
Okay.
Yeah.
But so if I was, so I may have gotten the two confused, but it seems like part of what you're trying to do is give a better account of serious actualism.
I was only briefly touching on serious actualism. So I do think, and I do think that there is a way to coherently spell out the serious version of serious actualism, which says that for a thing to have a real is for the thing to exist, and the only people are, existent things, the things which are denizens of other worlds, are merely possible people. They're not people, etc. And that was the story of adding rules like this, which I've written this in sequent form, but this is a rule of Pfefferman's free logic, and so Pfefferman is committed to the thing which will give you serious actualism when you add the modal story.
So the amplitude quantifiers, are those the outer quantifiers?
Yeah, the amplitude
okay,
quantifiers
all right, okay.
Yeah.
I think I'm tracking that. So it seems like maybe what the amplitude quantifiers are trying to do is to allow us to be able to quantify over different domains without collapsing them.
That's one way of thinking about it. I
one general
don't like the thought that to quantify, we first have a domain in mind, or something like this, because I think that the universal quantifiers are too universal for that, especially if you think a domain is a set. Because I want to talk about all the sets, including the domain, etc. can't you? Why not? But the ampliative quantifiers or the possibilist quantifiers are, just conceding the grammatical fact that singular terms that are introduced under context shifts are used outside the scope of those context shifts. I mean, this is the phenomenon of donkey sentences. Every farmer who owns a donkey beats it. What's the logical form of that sentence? Every farmer who owns a donkey beats it. Because here, every farmer is necessarily watching. If I say every farmer who owns a donkey beats it. Rendering this into first order predicate logic, kind of complex. Because we want to say, for all x, if x is a farmer, and there is a y such that, I'm a farmer who owns a donkey, so if x is a farmer who owns a donkey, there's a y, which is a donkey, and x owns y. I want to say that it follows from that what? Now, students want to say, x beats y, but this y is out of scope. Because this, so, but, English language grammar cares not for our scope. And, there's ways in, dynamic logic and things like that to, have a surface form which is much closer to this. But this is just an example of, being able to introduce discourse markers to not refer to things, it's not reference, because partly that's, which donkey? Say I'm a farmer who owns 73 donkeys. I mean, there's a way of reading this where, hey, if I own a donkey, I beat that donkey that I own. So if I'm somebody that owns 73 donkeys, I'm beaten 73 donkeys. Okay.
Full-time job.
Absolutely. If that's true. Thankfully, it's not true. No donkeys were harmed in the course of this example. But that's just an example that, and that's a case where that doesn't involve modality. But the other examples that we had with temporal shifting and counterfactual shifting does seem to mean that, we can use terms which in some sense get their value from other places.
And to keep track of that, at least if, it's either the exact information or at least the distinction, this is from another zone.
Absolutely.
So, and it seems that works well for maybe truth preservation, validity preservation with sequence, maybe even objectually. But I'm wondering if, since, reasoning is maybe even a bit more than that, maybe having to do with belief and justification, while S5 might work very well for the amplitude quantifiers, I wonder if, for instance, what we were talking about the other day, Williamson might worry, okay, for some of these zone shifts, it's fine, but what if, how specific can we get? How specific can our information, if you will, not epistemic possibility, but our information state access can be? So, in other words, for truth or truth preservation, maybe S5 works very well with the amplitude quantifiers, but maybe for reasoning, might we need a more restrictive or weaker logic?
Yeah, sure. Absolutely.
I didn't put that very clearly, but I think
the choice of the hypersequence structure was the logicians and philosophers' choice of, okay, we're just talking about supposing. Now, let's just put no restrictions on that, because no restrictions is both simpler and philosophers like generality. So it's like when we're talking about universal quantifier, I'm immediately, when I'm doing the logic of universal quantification, just going to be saying, right, I'm just unrestricted universal quantification, etc. So I've got to have to say something else about, contextual restrictions when it comes to you coming to the party and, bringing a six-pack or something, and I say, right, all the beer is here. Now, clearly, I didn't mean all the beer, because if all the beer was here, that's really surprising. That's a lot of beer, because there's a lot of beer. And if it was all here, then other people are going to be mad. And so that was clearly contextually restricted implicitly. Similarly here, we were just being totally abstract with regard to zone shifting and saying shifting is shifting and new zone grab. Two questions. Sometimes we want dependency between this. I want this zone to be dependent on that zone, this zone to be dependent on that zone. If I'm doing temporal reasoning, that involves zone shifts. But now I'm saying this zone is earlier than that zone, this zone is later than that zone. And so I've got to keep track of that. Second thing, when we talk about actual planning, or we tend to implicitly take a whole bunch of things as not changing from zone to zone. When I say, suppose we do this, and I'm talking about a choice that we might make. I might take it as background, that certain things that we take to be true of each other, that's in the common ground, is not only in the common ground as things that we take to be true, but we take those to be stable. And so I will take those to also hold as commitments in these alternative plans. Particularly when we are talking about what are we going to do when we go out to dinner? We might take it that our preferences are relatively fixed. I don't need to keep open the option that you have become a cannibal or something like that.
Yeah, in that light, it might. So, what I had in mind was, Williamson's trans world knowing objection from the Fitch subtleties. But if we're just making assumptions and we're keeping track of those then we're not. Then I'm not. Yeah, it may not be applicable. So, my question may not actually have a worry to it. Yeah.
Okay. So I think that. Yeah, it's over.
I have exhausted your patience.
Yes, no, the other way around. We are abusing you. Thank you so much. Let's